Hello everyone, my name is Ananya Pitamkar and I am a student from Sri Venkateswara College of Engineering. In this video, I shall be talking about next generation IoT based user authentication. The agenda for this video is abstract, introduction, model architecture, methodology, results, and conclusion. The research paper which I have referred is called Robust and Lightweight Remote User Authentication Mechanism for Next Generation IoT Based Smart Home. There are more papers which I have referenced and I have listed them in this video. If you are interested in knowing more about IoT based authentication mechanisms, you can click on the links which I have provided in the description. A smart home is an emerging technological revolution in which IoT enabled smart physical objects such as smart TVs, smart refrigerators, smart locks, etc. are linked to the internet to make human life more comfortable. The communication channels used by cellular communication are vulnerable and increase security threats, especially related to authentication. A reliable and portable remote authentication method is critical for ensuring safe communication in the next generation smart home environment. The paper which I have chosen proposes a lightweight and reliable remote authentication mechanism for the next generation of IoT based smart homes. In smart cities, different types of electronic smart devices such as IoT based sensors are used to collect specified data and transfer the data to central systems. The data is collected from different citizens, devices, buildings, and assets. The data is used to analyze and monitor the traffic, manage transportation systems, monitor power plants, manage water supply networks, criminal investigations, weather stations, pollution monitors, vehicle networks, home automation systems, and other community services. The data helps to improve the operations across the city. IoT based smart home appliances are increasing the volume of the internet day by day. The communication channels between remote users and smart home devices are vulnerable. It increases security threats, especially related to authentication. Therefore, security and privacy are necessary for the smart home environment. Moreover, data should be exchanged between two parties confidentially and without any change. Now let us discuss about the model architecture. The research paper introduces a lightweight authentication scheme by the usage of a hash-based method with a pre-shared session key to recognize the legitimacy of the remote user in smart homes. It proposes a secure and lightweight key exchange algorithm for resource-constrained smart devices. In the suggested system paradigm, the gateway or server serves as a connection point between smart devices and remote users. It offers an interface for preserving connections. By connecting to a gateway or server using internet-capable mobile phones or tablets, mobile users operate smart devices remotely at any time from any location. The proposed IoT-based smart system is composed of mobile users, smart devices, an access point, and a home gateway. The home gateway performs multiple roles such as registration authority, server, virtual router, and virtual firewall. Here we have virtually represented the model architecture of this model. Now I shall explain the methodology of this model. The scheme consists of the registration phase, login phase, key exchange phase, and authentication phase. At registration phase, each smart device is registered with a unique ID by the registration authority. This ID and the device status are stored in the server's database. The user selects a unique ID and password, and it is hashed into secure forms and stored in the server's database along with their email and phone number. At login phase, the user sends their hashed ID and password to the server. The server verifies them from the stored data. If they match, the user is authenticated. If login fails multiple times, the account is temporarily blocked for security reasons. If it is successful, the server sends two large numbers N1 and N2 to the user via a secure channel like the user's phone. After login, at the session key exchange phase, the user generates a large random number, computes a result using N1 and N2 and sends it to the server. The server extracts the user's number and generates its own large random number, repeating the same process to send a result back to the user. Both parties use the respective random numbers to generate a shared key, which will be used for secure communication. For authentication, the server and the user use the session key to generate hashed message authentication codes using their IP addresses and random numbers. These codes are exchanged between the server and the user to verify their identities. If the verification succeeds, the user is granted access to control the smart device. This scheme ensures secure authentication and key exchange, protecting attacks against attacks like man-in-the-middle or replay attacks. This scheme was implemented and experimented using Linux-based virtual machines in a client-server IPv6 network model by using Android socket programming, and performance was compared to other schemes. The results show that the proposed scheme, including the key exchange process, consumed less estimated computational time as compared to other existing schemes and reduced computation costs by up to 54.03%. When comparing the anticipated communication overhead of the proposed scheme with other relevant schemes, this comparison is called communication cost comparison. The amount of data transmitted through communication lines in packets and its size in bits per second are calculated as communication costs. Experimental outcomes display that the suggested scheme, including the key exchange process, consumed less estimated communication cost as compared to other existing schemes. The proposed scheme reduced communications cost by up to 25.28%. Here, the results have been graphically represented. Conclusion: the proposed scheme is lightweight in terms of computation and communication costs. It is more suitable for resource-constrained IoT-based smart home environments. The proposed lightweight and secure communication protocol addressed the key requirements for secure IoT deployments in smart cities and contributed towards making cities more connected, sustainable, and livable. Thank you for watching this video. I hope you learned something new and found this video informative. I have put the links of the research papers in the description. Don't forget to like and subscribe. Have a nice day.